Ken has a weekly goal for the number of calories he will burn by taking brisk walks. The equation y equals negative 300x plus 2,400 represents the number of calories y Ken has left to burn after x hours of walking. We're going to first graph this equation, and then after we graph it, we're going to use the graph to make a prediction. And the prediction is, after how many hours of walking will Ken have 600 calories left to burn, and after how many hours will he reach his weekly goal? So we could graph this equation, y equals negative 300x plus 2400, by using a table. We could create a table, but because this equation is already written in slope-intercept form, it will be much easier for us to graph it that way, using the slope and the y-intercept that are given to us. So slope-intercept form is y equals mx plus b. And in this equation, y equals negative 300x plus 2,400, the 2,400 is our b. And that means our y-intercept is going to be at 0, 2,400. So on the graph, we're going to go ahead and put a point on 0, 2,400, which is going to be right here, 0, 2,400. Now we need one more point in order to graph this. We need 2 points to do a linear equation. And so we're going to go ahead and get the slope next. The slope is negative 300x. So that's m is negative 300. What we really want from the slope when we're trying to do a graph is rise over run, which means we want a fraction. Negative 300 isn't a fraction, obviously, but it's really easy to turn a whole number into a fraction. All we have to do is take this negative 300 and put it over 1. So negative 300 is a fraction, can just be negative 300 over 1. If that really bothers you, you can be a weirdo and do something like negative 600 over 2, which is the same thing as negative 300, but let's keep it simple and just do negative 300 over 1. And the reason we want a fraction is because now we've got the rise over the run. So the rise is negative 300 and the run is 1, meaning from that y-intercept we have of 2,400, we're going to go down 300 and over 1. So I'm going to zoom in here so it's easy to see. The y-intercept, or sorry, the y-axis is actually measured by 100s. So to go down 300, we just go down 100, 200, 300, and there's our rise of 300. Because it is negative, we go down. He's burning calories, so calories goes down. The run of 1 means we're going to take a look at the the x-axis. The x-axis is not going by ones, it's going by halves, kind of. So we're going to, here's our 1 right here. So over 1 would be right there. It looks like I actually did a pretty lousy job of numbering this. Oof, gross. Oh my gosh, I gotta fix this. Oh my gosh, that is horrible. Did you see what I did there? I did the first batch as halves, and then I did everything else as thirds. That is not going to give us a good graph. All right, 1, 2. Let's go by thirds. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3. Oh my gosh. I thought I was going to save myself so much time by numbering beforehand, and I messed up on the very first one. Shameful. Shameful when the math teacher can't count. Holy moly. Okay, there we go. Fixed, hopefully. So now we're going to go over 1. There we go. Okay, cool. So down 300 and over 1. Now it looks like we're going down 3 and over 3, but that's because the x-axis and the y-axis are not going by the same amounts. That's okay, they don't have to. They don't have to go by the same amounts. So let's go ahead and grab our ruler and connect our dots here. And let's go all the way across. There we go. All right, so there's our graph. Looks pretty good. So our graph there says that somewhere around here is when he's going to completely burn all of his calories. In fact, I probably, if I want to be a good mathematician, I probably should stop right there. I don't really want to go into the, really don't want to go into the negative, so I'm going to make sure my line stops right there. And I think actually, you know what, my line needs to be a little bit better. My line doesn't quite go through those dots, and if I want to use my graph to make a prediction, I really need to make it go exactly through those points, because we are going to have to do a prediction here in just a second, so I really need to do a better job. Make my graph as accurate as possible. There we go. Okay, I like that a little bit better. Let's adjust this arrow. Want to make it, if you want to make predictions, you need a good graph. Okay, so right about there, it looks like, is where we're going to hit 0. Okay, so that feels like a better graph because it looks like it's actually going through our 2 points. Okay, so let's go back to our questions. Our questions, the things we were trying to predict were, after how many hours of walking will he have 600 calories left to burn? So our y was where we were doing calories. And the reason we know that is because the problem says the number of calories y. So our y-axis is where we were doing calories. It says 600 calories left. So on the graph, we would go to 600. And that's right here. There's our 600. And it looks like, if we zoom in here, 600 calories looks like, what is that, a little bit more than 6 hours? Like 6 1/3 hours? 6 1/3 hours looks like a pretty decent estimate to me. And 6 1/3 hours is 6 hours and 20 minutes. A third of an hour is 20 minutes. So I think we're going to say after 6 hours and 20 minutes, that is a lot of walking. After 6 hours and 20 minutes, he will have 600 calories left to burn. Is that how you spell calories? No, that's calories. Spelling. When are you going to use that in real life? Calories left to burn. Okay. After 6 hours and 20 minutes, he will have 600 calories left to burn. Now, the second part of the question is, after how many hours is he going to get to his weekly goal? So his weekly goal means he has burned all 2,400 calories. That means he's got 0 calories left to burn. And 0 calories means we have hit 0 on the y-axis, 0 calories. And that's where that blue arrow that we drew is, right here. And that looks like it is exactly 8 hours. So after 8 hours, he will hit his goal of burning 2,400 calories. Let's see if I can spell calories right this time instead of calories. 2,400 calories. So we used the graph to make a prediction this time. We could have also used the equation to make a prediction instead of the graph. That's something we're going to learn how to do a little bit later, is how to, instead of creating a graph to make a prediction, using an equation without the graph to make a prediction. So that's coming up soon.